And thank you. And as I have our other panelists come up here for software, we've been hearing quite a bit today about hardware, fantastic hardware and how it gets put to use in the center. An analogy I'll use is all this hardware we've been hearing about is like buying an awesome new car, but not driving it. It's the software and the data coming together that really makes that total solution. So with the panelists up on stage, let's get into the software part and start talking about how it all takes shape and comes together. So as we take seats here, John right there.
Or my formal ones.
So why don't we go on down the line and go ahead and introduce yourselves to the audience and say a little bit about the company as well as what you do at QCT.
Sure. I'm John Zanos. I'm Vice President of Cloud and Business Development and Alliances. In my spare time, I'm also part of the OpenStack Foundation as a board member, as well as OPNFV. We're doing a number of things with QCT, including developing OpenStack solutions on Quanta platforms as well as on OCP-oriented architectures. Mike, thank you for having us. It's a pleasure to see your facility completed. It's beautiful. I also had the benefit of meeting your great team, who is very energized over dinner and very impressed in multiple ways. But lastly, I will say that also a great opportunity to meet your partners and customers. So we had, thank you very much.
Howdy, I'm Jeffrey Snover. I'm a technical fellow in Microsoft's Enterprise Cloud Group. In the Enterprise Cloud Group, we have products like System Center, Operations Management Suite, which think of as like managing products run from the cloud to manage everything, as well as Windows Server, and then Microsoft Azure Stack. Microsoft Azure Stack is where we take our public cloud technologies, Azure, and then we run them on the customer's own hardware.
Mike Evans from Red Hat. I've been at Red Hat for 15 years and currently look at new markets and new technologies. And to me, it's exciting. I was telling Mike earlier to see, I've seen Quanta behind the scenes for up 15 years with working with Intel and some of the other system vendors. And it's great to see them come out of the closet, so to speak, and put their face forward as a player in the market. It's very exciting. We're engaged with Quanta across a number of our products with classic Linux technologies, virtualization technologies, quite a bit on storage, quite a bit on OpenStack, and expect things like containers to also involve a lot of the systems that they're developing as well.
Excuse me, may I interrupt? You just mentioned out of the housing, right? You modified a little bit because you have a check in the box, right? So QCT is out of box.
Out of box, okay. You're out of the box now. You're more visible. I like it.
Hi, I'm Raj Javatkar. I'm a fellow at VMware and lead the new product category for VMware called Evo SDDC or Evo Software Defined Data Center. And that's our way to deliver to the enterprises and service providers what we like to call easiest way to procure, build, install, deploy, and operate a software defined data center based private cloud. And when I started this project at VMware last year, the first person I thought of approaching for partnership was Mike. Mike I call the equivalent of Energizer Bunny for the Hyperscale provider. So he was very gracious and he has been a great partner with QCT and we are delivering this solution to the marketplace jointly. So very excited to be here. Thank you.
Good afternoon. My name is Jianyao Chong. In case you don't know how to pronounce, just call me JY. I joined QCT about 14 months ago. Before that, I was with IBM Research. So being from research into QCT is quite a different experience. In the 14 months, thanks to Mike, about 6 months ago, we have our first solution center in Taipei. And now we are here. And I just heard there might be another one coming up. Before that, and also, I really like to thank all the people here. When you go to the solution center, you're seeing the boxes, there's all kinds of server, but we really appreciate the key parts. That means the processors, the RAM, the SSD, the HDD, and really appreciate your support. Your support is not just giving us the key parts. We work with different partners to build solution on top of it, and we are continuing to do that. So we really appreciate from all the sponsors, and we should continue collaboration. And my current responsibility beyond setting up a solution center, I'm responsible for the Microsoft product line, the big data product line, and also the most important part is the software-defined storage product line. Thank you.
Hi, good afternoon. My name is Gary Lee. I'm from the QCT engineering, solution engineering team. I joined the QCT less than 1 year, but for the past year, it's a very challenging and fruitful journey. Thanks for all the partners that within the years that we worked together with a lot of partners, including the VMware, Red Hat, and also Mirantis in the OpenStack, and also the Canonic in the OpenStack areas. Let me tell you, 1 year before this, that's very few solutions in other areas from the QCT. That we actually come out with the different partner strengths and also the rich product portfolio coming from the QCT. We integrate all the solutions together within a very limited time. But based on that, we actually continue to accelerate all the process, bring a lot of the some of the requirements coming from the different partners and then some of the from the real customer itself. So I would say that during the last journey, we actually have the full speed moving to develop the solution. And moving forward, I think we have even more the solution in front of us to develop for that area. And thank you for your coming. I think it's very exciting today for all of you coming over here.
Terrific. So there was a recent McKinsey study which elaborated that moving forward for on-premises clouds, it's going to really come down to VMware, Microsoft, and OpenStack. And up on stage here, representing our companies and partners with QCT, we have all of us here. So are we friends or enemies? Is it one man win all? Is it collaborative? Why don't we start on the far side there with Raj? What are your thoughts on this?
So I think if you look at OpenStack, let me start with that. What are customers looking for? They want a vendor-neutral ecosystem of tools, so their developers can build applications in a vendor-neutral way, right? At the same time, those same customers, which are the providers of those customers, enterprise IT, they rely on VMware for all the cloud management platforms, tools. So what we have done is we have become the largest distributor of OpenStack as of now. And we have been able to deliver a product called VMware Integrated OpenStack, which is in deployment now at about many customers. One of the large retailers has about more than 3,500 VMs running on it. So we believe that we bring the best of both the worlds. We bring OpenStack as a way for people to be invest in a vendor-neutral ecosystem while providing fastest time to value and lowest TCO. So we have done analysis to see that using our tools while maintaining the compatibility with OpenStack APIs, we really can bring both the worlds together to deliver to the customers what they need.
Mike?
Sure. So regards to OpenStack, one of the ways I see it is it's similar in some senses to Linux in the early days in that it's a supersized Linux almost. It goes deeper in networking, deeper in storage, deeper in compute, and a little bit higher up in functionality, but it's still operating software that you need applications to run on. So there's some similarities. One of the differences from when Linux came out in the early days 10, 15 years ago and gained popularity to OpenStack is that in those days Linux was really sort of copying Unix in some senses and making it lower cost and easier to use, and it just gained market share that way. But if you fast forward to the last 3 or 4 years, the open source community has taken on a role of being innovators instead of just sort of mimicking and making it lower cost. And the data that I use for that is you show every new major technology, whether it's big data and Hadoop is very Linux centric, whether in open source centric, whether it's things like MongoDB and Cassandra databases OpenStack came about and was Linux and open source centric. Containers are Linux based. So the difference now is you have open source technologies innovating, and I think it's going to coexist for a long time with especially VMware and Microsoft, given their breadth of installed bases. But I think you also see two traditional proprietary vendors adapting to it somewhat. I would say defensively is the way I view it. You know, they have to.
I would say aggressively, but that's okay.
They would prefer not to. I mean, to the extent that you even see Microsoft, I think part of their switching network is Linux based. So Microsoft's done a lot to open themselves up and embrace Linux. So I think they're going to play out together for a long time. OpenStack is a fascinating beast. I jokingly call it the solar-powered saltwater desalination plant that cures cancer and Middle East peace all at once, if you believe the press. And it's a great technology with a lot of promise. It's also has a lot of moving parts and is very complex and is getting easier. And we think from Red Hat's position, you know, it's an aggregation of Linux, virtualization, which KVM is the most common virtualization used, and OpenStack code that makes it a system. And we think we're in the best position in terms of building an ecosystem around that system, having it all be open, be a trusted supplier. And we think that's what's going to be important in OpenStack, but it's not going to kill either of these guys in the next 3 years. So,
Jeff.
Yeah, so when it comes to the cloud, we are competitors and we are collaborators. When it comes to the cloud, Microsoft's position, I'm very, very, very comfortable with our position in the cloud. You know, a lot of customers, a lot of competition will tell you why, you know, they have a vested interest in the public cloud, and they'll tell you why the private cloud is doomed and it's terrible, et cetera. Other of my competition have a very vested interest in the private cloud, and they'll tell you why the public cloud's a disaster and it's a security problem, et cetera. Microsoft has plays in both. And what that allows us to do is to focus in on the customer's needs and what is right for the customer, and then we're going to provide them a solution, whatever that is. And whether it's in the public cloud or in the private cloud or together, or if they're not sure, they can start off in one place and go to the other. So again, I'm very, very comfortable with our cloud position there. So at that level, you know, we compete. We have different value propositions. But what we don't talk so much about is the degree to which we collaborate. Look, we all face the same problems, right? Drives that don't work, stuff that's very hard for our customers to integrate. We have a concept we like to talk about called data center plug and play, right? Anybody ever get a CD-ROM before plug and play, right? You remember the bent paper clips and the tiers and the I/O maps. It was just horrible, horrible experience. And these days, you just go, you get a DVD, you go buy a DVD USB drive, you plug it in, put the drive in, and it just works. Now, how many of you have that experience with data center hardware? Right, 0 hands raised up, right? But why not 1? I think you're lying. But why is that, right? And the answer is, in the days before plug and play, we had lots of proprietary ways of doing things, everybody off on their own. And what we did as an industry was we came together and we said, hey, let's define a set of standards so that we can find and discover the hardware. Let's be able to use standardized protocols to enumerate what the identity is and its capabilities, find the appropriate software, and then bring that element into play by our, use by our customers. And we believe that we can do the same thing when it comes to data center components. So behind the scenes, we're working with a number of these folks to do that very thing, to establish the protocols and the conventions so that you'll be able to have a data center plug and play. And it benefits everyone, right? No one benefits by making it hard to buy a new piece of hardware and introduce it. Nobody benefits when a customer has to spend weeks trying to decide, yeah, is that going to work? Is that the right thing? Is it going to work with this or that? So anyway, so we talk about competition a lot, but there's a lot of collaboration that goes on as well.
Yeah. John.
Yeah, well, good points by everybody. I think, you know, the term of choice is frenemies, right? And over time, we'll figure out how friendly or not. But I think at the end of the day, collaboration is going to be rewarded. Why? Because our customers are demanding it. Collaborating with QCT is about making things easier. Those that collaborate and simplify will get rewarded. Those that do not will get penalized. So from my perspective, when we talk about it, we talk about a cloud, the cloud. No public cloud, no private cloud. Almost to a T, all our customers have a foot in each camp and are doing 16 proof of concepts with VMware, with Azure Stack, with Ubuntu OpenStack, with Red Hat OpenStack. I can think of customers like AT&T probably have 16 proof of concepts just by themselves. Why are they doing that? They're trying to find the right path to simplification, because what they care about, as the previous panel was talking about, is making the hardware platform seamlessly work, that they can put applications that make them lots and lots of money. And that's all our job, right? To help our customers make lots and lots of money and have great experiences. So when I think about it, I think it'll be all about collaboration. There was a piece of press not so long ago that Microsoft talked about Ubuntu being the preferred operating system for the cloud. I mean, the collaboration happens. I think the time we spend talking about the lack of collaboration is really just the tiny piece of the pie. All the other work that happens every morning with all our engineers on IRC, on email, is about collaboration. You know why? Because engineers like making great stuff. As Mike said, you know, the engineers in QCT like making great stuff. We like our stuff on top of great stuff. And you know what? Our customers like their stuff on top of great stuff. So when we weave that all together, we're usually collaborating more than we're not. And that's where I think the future will go.
I agree. I think, you know, the fact of the matter is, very few companies are going to be public cloud only. Equally, very few companies are going to be private cloud only. Reality is it's going to be a hybrid world, and in most cases, there's going to be at least 2 flavors of cloud within that overall Uber cloud. And that's the reality behind bringing this together and the collaboration.
Well, it's also worth pointing out, as you mentioned, that when we remove friction from the system, we believe, and I'm sure you do too, that when we remove some of those problems, the pie gets bigger. You know, as an industry, we've finally gotten pretty good, a number of us have finally gotten pretty good at being able to translate investment in computing into bottom line profits. And when you can do that, when you can eliminate the friction and make that smooth, you know, the checkbooks come out. People start writing. We all benefit.
I agree.
So we heard a little bit earlier today, actually a few times, software-defined networking, software-defined storage, software-defined infrastructure in general. So where do we see this going? And is there a future for hardware, or is it all in the software? Is it the combination? How does this play together? And Mike, why don't we start with you? We'll come this way and we'll get back over to Raj.
Sure. Well, I think there's multiple questions in terms of there's timing questions are sort of one vector of that, is what is the timing of the evolution of the software-defined everything. There's been big probably the most controversial or most disruptive advances in the recently seem to be in the networking side, in my mind, in terms of software coming deeper into the networking world. In parallel, there's the storage one. Those are 2 markets where you have very big, large vendors in those market segments that want to hang on to their classic hardware business in those areas. So those 2 are the ones that I see right now being the most disrupted and the most opportunity for people like all the software companies sitting up here to take advantage of. I think unless there's a major breakthrough in the way that software can run on air or something, I don't think you can hear, just listening to the panels here and seeing what Quanta is able to do with the hardware themselves. You know, it's just fascinating how everyone's sort of trying to get their part to be the fastest, best, cheapest, right, in combination, and then how it links into the next guy's piece and where's the bottleneck and that evolution. It's just to me it's fantastic because it's creating change, and change creates jobs, change creates new companies. It forces the old fat guys to get off their ass and adapt and move to it. I mean, that's what I see as the software defined stuff is sort of forcing everything to change and go forward, and everybody is kicking everyone in the ass. hardware and software to move faster. So I don't know. I don't have any great predictions for it. I just love it personally.
Scott warned that 4-letter words would be coming out before too long up here. So.
Kick ass.
All right.
Ass is the 3 letters.
It's 3 letters. We're almost there. All right. So Jeff, your thoughts on this one?
Yeah, you know, I just caution people against these kind of like press fights that fights that the press tease up. You know, software-defined. Software is going to consume the world. Here's the secret. There's a lot of hardware acceleration required for software-defined anything to work, right? Our software-defined storage, boy, that works fantastic when you have RDMA NICs, or friends out there on the panel earlier, work closely with them. And when they do their magic there, boy, our software gets really, really fast, and these converged fabrics make a lot of sense. So there's always a lot of investment in hardware. Now, one of the more interesting things that's going on is, now that said, it's just a statement of fact that as you move the error detection up the stack, 2 things happen. One is it's harder to deal with, right? More people need to deal with it. But it also gives you greater scope, so you have more possibilities for what to do about it, right? That's why we all use TCP/IP instead of SNA. SNA did very low-level error handling and was very, very expensive, very fragile, very brittle, not very agile. You move that up to the IP layer, and you get a ton more, dramatic decrease in cost, much more agility, et cetera. That said, most people deal with TCP. In other words, at some point, there's got to be a pinch point where if you take all the error handling and move it all the way up the stack, it's very complex to deal with. Anyway, so this challenge between software-defined networking, software-defined storage, software-defined compute is all about us as we innovate every layer of the stack innovates, trying to find the sweet spot for where's the right place to define what task, right? Hardware offloads, unambiguously the right thing to do. Putting lots of policy decisions low level, we found that doesn't work very well. So we put that in the software, and do we put it up so that every application deals with it? The answer is no. We put it in the OS layer. So anyway, the key story, I agree, it's one of the most exciting times of the industry. You know, in the past, industry would be relatively static and you'd have a revolution. It seems like right now, every single layer of the stack, from the technology to the chips, the system architecture, the rack architecture, the software, storage, networking, operating systems, containers, every single layer of the stack is undergoing deep rethinking. And that's why I caution anyone to think that they have any good beat as to what's really going to happen more than 2 or 3 years down the road, because these things are going to combine in ways nobody can anticipate.
John.
Yeah, I agree with the points made, and I think it's really important to understand what's base driving this. In my assessment, what we're really seeing is an abstraction of the software stack from the hardware stack. Is that about relative importance? Absolutely not, right? As everybody was saying, the hardware stack has to operate seamlessly well, be optimized and innovate, so does the software stack. So why are we seeing this drive for software X, software networking, software-defined storage, et cetera? Because there's a drive to try to commoditize each one of those pieces. And when you make them layers that are interchangeable, what do you drive? You drive options for our customers. So I think what's interesting with software-defined networking, for example, I think it's the same for storage. That software stack will be able to exercise advantages that reside in the hardware, certain disks, certain networking pieces of equipment, but the abstraction will afford the customer to make that choice as compared to network appliances of old where Ericsson or Alcatel-Lucent made that choice. So the value is the abstraction that adds flexibility to the customer to interact with all us on the software side, all you on the hardware side, and say, I really like option A with option B or option A with option D. And in the case of Microsoft Azure Cloud, you're making those decisions. In case of customer XYZ, they want to make those decisions. I think what's really exciting when you look at the next 3 years is that the market's going to be driven to drive innovation rapidly at each layer, but afford the layers to be somewhat abstracted so customer choice is preserved. And I think that's what's going to be very exciting for all of us.
Raj.
Yeah, I didn't get to respond to Mike's comment about 3 years. We have only 3 years before. I want to respond to that and then take the question, if you don't mind. Yeah, I think the Linux evolution is a very good example. But I think if you look at the OpenStack, what people are trying to sell might be a mistake, because just like the Linux, what made it easier to adopt Linux as a standard? Because Red Hat made the packaging and managing and tools easier. And that's what people are looking for. So OpenStack is not a panacea unless you have a very easy way to create operational simplicity through automation and all. And that's irrespective of whether it's OpenStack underneath or what any hypervisor you use. So going back to our question, I think no panel is interesting without some controversy. So let me take a point of view that proprietary hardware is dead. So when people talk about hardware defined, they usually mean proprietary hardware, adding value. I worked on TCP/IP offload. I never thought somebody will mention SNA, but Jeff did. So I was really surprised. Only 2 of us understood what he's talking about. Everybody else is younger. So I think if you look at people when they talk about a hardware-defined infrastructure, they say really mean proprietary hardware. And what has happened is that Moore's law has made x86 this industry standard platform to do anything, not just compute. Compute, obviously, it is a standard, but now you can do a lot of network processing without offloading the network processing using DPDK or whatever tools you have. Same thing is happening with storage. You can put a lot of the functionality, you can run them out of hypervisor on x86. And that's the industry standard platform you can create, making proprietary hardware unnecessary. So that's the biggest difference I see. And when I look at what John's comment, he's absolutely right. What you're creating a new abstraction which makes you hardware agnostic. That does not mean the hardware has to be cheap or unnecessary, but it becomes, by moving a lot of functionality that is embedded in hardware. Network virtualization is a very good example. It's a big disruptor. So it's storage virtualization. What they're doing is they're creating a new abstraction which computing already has across all these resources, so that you can be hardware agnostic and move a lot of functionality is necessary into the software, because x86 hardware just gets faster and faster in terms of both I/O and compute. I/O architecture in x86 is amazingly evolved in the last 6-7 years. And that has made a huge difference.
Perfect. Yeah. So on to the next one, and here we'll start, why don't we start here with John, we'll go on down the line that way. So looking at either rack scale architecture and or OCP, we've heard a lot about some of that earlier today, particularly on OCP. How do you see that shaping up in the future, and what's your company doing with either or both?
Okay, excellent question. I think it maps a little bit to what we were just talking about. First of all, I think what's interesting for me for OCP, for example, but I think it applies in both cases, is that it's a community-driven sort of architecture development, and why that's relevant, where customers are getting vocal in what sort of hardware they'd like, how they want it designed, what use cases they're using it for, while at the same time trying to preserve the very abstraction we were just talking about, which is about preserving choice, right? For us, like when we look at OCP, we're very active in both efforts, and we're active in tracking it and also contributing to it. So what our goal is to help make the operating system work seamlessly well with all the different sort of scenarios that are being discussed, and enable that hardware to be utilized by whatever application sitting on top of it. So affording some of that abstraction, but not sacrificing efficiencies. In the case of OCP, I think the positive side is that they're being very aggressive in looking in different things like their network standards. I think one of the questions we all have to ask with these efforts is make sure they don't lose their way. Make sure that they develop things that are scalable across multiple customers and valuable to the market in general, and not narrowly focused on 1 or 2 active participants. And that's more of a comment, not on either initiative, but just on the challenges of technology innovation in community-driven projects. But from our view, we like to see both happen, right? We like the collaboration with companies like Microsoft and QCT and others, and that drives innovation. And you'll also see us be very present in big efforts like Intel's and big efforts like OCP, where you're trying to accumulate multiple opinions to drive innovation as well. I do think, the famous statement that software is ruling the world is less about software itself, as about software as a point of collaboration to drive innovation. And that cascades, in my opinion, not only through the software, but also through the hardware.
Interesting. Jeff?
Yeah, so Microsoft has always been about doing very expensive, very important computing on value-add or value-priced hardware. Okay, and so we are very active in these environments to work with the various vendors to take very high-end scenarios and then put them in hardware that's going to be value priced. We think that's important for our customers, and we're also one of the largest purchasers of servers in the world. So we have a very strong vested interest in these initiatives working as well. And it's one of the things I think is so exciting about the industry at this time, right? In the past, you used to have people that would make some great innovation in hardware, and the number of people that could then adopt that, the adoption cycle was low, and therefore the pricing remained high, and it's hard to get that virtuous cycle of volume high enough so that the prices could get dropped. And now with some of these consortium efforts, we're able to work together as an industry to drive some great innovation, and then all of a sudden buy a gazillion of them so that the payback happens very quickly and the prices can drop, and then our customers can benefit from that as well. So we're very active in these efforts, and we think they're great.
So I think it's kind of a two-part question. In terms of the OCP, that's Red Hat was one of the early members there, and when I remember being approached by Facebook and others when it came out, and it was kind of a no-brainer. It was nothing but goodness from our perspective, and people contributing more and a more open mindset consistent with our sort of development and business philosophy. So I've watched that grow and seen it make impact and strides in the market, which is great. In terms of scale, that's another area where I remember 3 and 4 years ago being on a panel that it talked about every major cloud, whether it was Amazon and Google, were built, every major cloud anyway has been built on open source technologies at their foundation, with the exception of one. But that's starting to change even, that they're starting to build. And I actually made the comment, there was a Microsoft guy on the panel, that I don't think you're going to be able to go forever just doing everything yourself because there's such great technology. So at Red Hat, one of the ways we look at taking advantage of these high-scale environments that are being driven, a lot of them Linux and other open source technologies, is we don't see our job as trying to build the software for Google's cloud underlying as our job, as our main job, even though they use the KVM virtualization stuff that we work with them on. But that's not our main mission, is to sell Google a hypervisor to run their cloud. Or our main mission is to take the best elements, and luckily for us in the open source model, a lot of these elements are created in these scale environments. Same with high performance computing, which 99 out of the 100 top HPC results for the last 10 years have been on Linux. So these things are done out there, and our job at Red Hat is to take them, make them manageable, consumable, and reproducible for the mere mortals, if you will, or I call it the people who like to go home at 5 and watch their kid's soccer game, not the people that are creating Google's next infrastructure. So for us, it's a matter of being a participant in these wide scale, mass scale deployments, whether it's Linux, whether it's OpenStack, whether it's container technologies, whether it's storage, being one of the drivers. We have thousands of engineers that participate, but taking that and then making it consumable, manageable, usable by 90+% of the market instead of the smaller number of major scale players out there. It's interesting because a lot of times people will get new sales reps at Red Hat and they'll say, come on, let's go win Facebook's infrastructure. Let's go win Twitter's infrastructure. And I say, knock yourselves out, but it isn't going to happen. And that's not how we look at them as customers. We look at them as development partners in this, and that's super valuable to us as well.
Raj, how about you?
So I think in terms of VMware, where we look at QCT-like companies very successful because they work with hyperscale providers who have brought very different level of economy of scale and operational efficiency to the cloud. right? If you look at public cloud guys, and at least one of them has publicly stated that their ratio of operators to servers is 2 orders of magnitude less than the large enterprise. We want to bring that level of efficiency to our enterprise customers. And to do that, I think Intel is the right partner for rack scale kind of architecture, because what the previous panelists mentioned, that financial services example, that people think today of buying a server as a cloud platform, which has, you have to make a choice of disk, storage, amount of storage, SSDs, HDDs, network bandwidth, and so on. With rack scale, Intel's view is that starting with the hyperscale guys, they want to bring this platform disaggregation to the market, where you do not have to make a choice about amount of compute, amount of storage, amount of networking when you buy a server. Instead, you should be able to dynamically compose a server out of disaggregated components. And somebody on the previous panel also mentioned the server should not be the unit of computing or abstraction for management, rack should be. We should be able to think of multiple racks, because to bring the scale for operational efficiency, you need to do that. So I think rack scale architecture, where we are working very actively with Intel, the goal is to really disaggregate the hardware components, allow for dynamic composability, but also start thinking in terms of scale of multiple racks. So I think that's another big change. Even though it's driven by hyperscale guys, Intel, as you know, it defines the server hardware platform, right? Nobody else in the industry can match that, because no matter what the OEM say, Intel tends to define all the platform components. So they will make it happen, and they are driven by the hyperscale guys, but there's an opportunity for people like us to bring that level of efficiency and scale to the large enterprise customers and service providers who are not hyperscale providers, and they do not have the same economy of scale. So that's why we're working with Intel, yeah.
Perfect. And we intentionally saved this one as the last question. You can't get through 2015, particularly on a software panel, without talking about containers. So Dockers, Kubernetes, Cloud Foundry, et al. So how is this changing software delivery, applications? Who are the movers and shakers, and how does this play out over time? Why don't we, Jeff, you haven't started one yet. Let's go down the line, and then John, you get the last word, the almost last word.
Yeah, so we're very excited about containers. We obviously have seen some of the Azure announcements where we've been working with Docker and a number of the other Mesos. We just offered containers as a service in our public cloud. We are also developing containers for Windows. And when we do it for Windows, we have 2 flavors. One's called Windows Server Containers, which is effectively the Linux containers, and then a more isolated version of that called Hyper-V containers. And that's more oriented around computing for hostile multi-tenancy environments. This really is a new architecture. It's one of the things I'm most excited about, as we have to take this, incorporate it into our architectures, do the deep rethinking. I mean, one of the questions was who wins and who loses. Clearly the folks who lose are the folks who are going to stay in the past, be comfortable with where they are, who few are, kind of resting, investing. What'd you call them, the old fat guys? I was wondering whether you were looking at me when you said that. But those guys who are not interested in adapting, they are going to lose, right? If you weren't interested in the fast-moving pace of this industry, you should have gotten into forestry or lumber. This industry moves, and it moves fast. Containers is one of the fastest moving things I've seen in my career, and it really does allow a completely different way to do things. Now, how that plays out, I'm skeptical. I think it's going to take us a while. I kind of liken it to saying, what happens if you had a third arm? What would you do with that? Well, you could think of some things, but the answer is you'd have to use it for a while to figure out what you could do. I think it's that level of disruptive, and it's going to take a while.
A third arm, all right. Mike.
Yeah, so containers is another example, as I mentioned, of a new technology, disruptive or a sort of a better way of doing things coming about. And for us, we feel great that it's open source based, and that it happens to be Linux based as well, puts us in a great starting position.
Well, you're just banging that gong.
I know, it's people don't.
See, that's the non-friendly part.
I didn't know there was any other operating system in cloud, only Linux. So you don't have to emphasize that.
No, well, that's another, yeah, all right. Well, thanks, though. But the containers are also in the, I'll use a technical term, the goat rodeo stage right now. I mean, if you try and figure out, what are all the piece parts you need to develop an app, to find it, secure it, make sure it's securely run, to manage it, to scale it, to update it. That's a wild swirl right now. It's exciting because developers are grabbing on, and that's the most valuable forcing function that you can have. When developers say, I'm going to do this, I want to use it, then the IT people have to adapt and figure out how they're going to manage the deployment. So that's kind of what's happening. It's in my mind, the battle is over. It's the next development platform, an application development platform, whether it's 3 years, 5 years, 8 years. That's the battle. And when you have a new strategic software position like that, like OpenStack is another one where in my mind, there's only a limited number of strategic software positions. Databases is valuable, operating system, a virtualization layer, a middleware layer, and OpenStack is an infrastructure as a service layer. And then getting the developers is sort of the crown jewel of that strategic software. So that's why you have it being a mad scramble with, IBM with a position around Docker and/or Docker variants, and HP with a position, and the EMC entities and Cloud Foundry and various members, and Red Hat with a position. So in my mind, the battle is partly around how the container plays out, but probably who's going to win is the one who gets 50 to 60% of the developers to develop on their model, and platform as a service comes into play quite heavily in that model, because there's a limited number of developers in my mind that will write to the container. It's a lot of the same hardcore developers that sort of wrote Wall Street applications, but the mass market is probably much more likely to adopt something like a platform as a service. I have a plug. Red Hat has one called OpenShift that competes with Cloud Foundry and Google App Engine and Microsoft's App PaaS kind of platform. And in my 15 years at Red Hat, it's the most sort of rapidly growing, most desired product I've ever seen in 15 years, and we barely advertise it. So I think it bodes well, but I think as was mentioned, the people that are going to lose are those who sit still and watch it happen. Right? There's that old saying, there's those that make things happen, there's those things that watch what happened, and then there's those that wonder what happened. And if you're the last category, trying to hold on to yesterday's model, you're going to be in trouble. But everybody on this panel is gung-ho containers and trying to be one of the players in that game, and it's a big prize that I see for whoever gets a major market share there.
Raj, what does it look like on the VMware side?
I think Mike is absolutely right. I think he made very good points. I just want to start with the business problem that the containers were invented to solve. Right? Developers want the fastest time to be able to stand up an application and be able to deploy it to any cloud. That's the problem the containers are trying to solve. Now, Jeff might appreciate this. A long time back, when the Unix became popular, people invented something called LWP, a lightweight processes that Sun had. It is exactly the same reason that people did not want to invest in these big processes, spin them up every time, and how can I construct my application to be multi-processor but within a single process. Containers are doing similar things. They are trying to provide you a very quick way, but at the same time, they have to deal with the same computer science problems we have to solve. How do you provide data protection? How do you create secure sandbox? So you can play in a container, but you can't be attacked by side channel attacks. And VMs provide that. Virtual machines provide you those advantages, but of course they are big, fat, and happy compared to containers. So how do you marry these two worlds is really the challenge. And VMware, for example, we started collaborating with Google right off the bat and have put out two products, one called Photon and the other called Photon Machine. And what we have done is side by side, we provide you two options. You can create containers using microvisor, so you get a lots of efficiency and fastest time to value with containers. We also can use some kind of a copy on write semantics, so we provide data protection. So you don't have to give up the protection. But we also provide you another way of doing containers, which comes with a lot more secure protection. So I think the jury's out. As Mike said really well, this is about capturing the mind share of developers. And there's going to be a big race here across all of these players, people on the panel, as well as people like Google, and others have jumped into that. And I think Docker is focused more on packaging. the interesting problems to solve and deliver are the developers' problems. When they stand up an application, how do you still provide efficiency of spin up as well as being able to deployment, but without losing security and data protection?
And John?
This is fun. Containers are very interesting on multiple fronts. As everybody said, we all have a play in this, and it's because it's important. So let's talk about some of the fundamental drivers, as Raj said. Why are we worried about containers? Because we want to get code out quickly. Why do we care about code going out quickly? Because companies like Uber and Boeing make lots and lots of money because their code's better. So there's a big driver that didn't exist 15 years ago, right? So containers actually have been around for a while. We've had containers, IBM's been involved, Google's been involved, I know Microsoft's had projects, Red Hat's has products. But what's happened recently is Docker has made it very interesting, right? Because it's been very elegant. What's interesting for all of us is that we all have a role in that, and Kubernetes and Cloud Foundry, a lot of companies are focusing in this area, Mesosphere. But what's really interesting to me is the root thing that's happening. What's happening? So every once in a while, I go between Boston and San Francisco, as well as other cities. So I get to go to MIT and Stanford. So the question is, what are the 21, 19, 18, sometimes 14 cool kids riding on, right? They're riding on containers. We're lucky. They're many times riding on Ubuntu. And what they're doing is creating the next Uber, the next Airbnb, and they want their code out quick. And why is that important? Because what they're trying to do is create the next company that comes out quicker. And if you've seen any of the Fortune or Harvard Business Review analysis, where we live today in a time spectrum is the most interesting moment in time, because the cycle times for new companies to come from 0 to $1 billion in terms of valuation and revenue is the shortest it's ever been. Why is that? Because technology enables very rapid market penetration. Software in conjunction with hardware creates new services that are out in the marketplace. Think of how long it used to take to design and build a plane. Now a company can become $1 billion company in the course of a single year. People kind of almost graduate from Stanford, but they actually start their company and postpone graduating from Stanford. And then that company's worth $1 billion before they actually finish graduating from Stanford. So that is the key driver. From my perspective, what's interesting about containers is that containers is basically enablement of microservices. And microservices is about writing code in little buckets very, very quickly and very, very efficiency. And that efficiency is what we all talk about, right? We want operating systems to enable that. We want hardware to enable that. We want tools like Kubernetes, Cloud Foundries, et cetera, to enable that. But what we really want to enable is all those cool kids to write stuff on our stuff, because those will be the next group of $1 billion companies. And what's fun about our industry, you know what happens to all those cool kids? They become the old fat guy sooner or later.
Why'd you look at me?
Well, I was going to learn. You're the closest.
Yeah. So yeah, to add to that, I think containers have been around for decades.
Sorry.
But if we think about containers of yesteryear, it was all around IT deployment of applications and isolation and so forth. And when we think about containers now and moving forward, it's all about the developer and being able to package and deliver applications with all the dependencies, making it extremely simple. The whole microservices ability to do that and roll that very, very quickly and have a very highly reliable rollout across one or many data centers. And if I take that up even one level higher of abstraction of where OpenStack is going and where all of us here are really trying to take the industry, certainly on the OpenStack side and Miranta's side from my standpoint, is a data center of the future where we can have not only virtual environments, which is where OpenStack started, but bare metal environments through Ironic, which is a project in OpenStack, to have containers, whether that's in virtualized environments or not, perhaps container environments completely without virtualization underneath with a Kubernetes cluster. All of these orchestrated and managed together in the same data center on the same cloud. Very, very effective and be able to balance those resources. So to take it over to the QCT team, Gary and JY, why don't you add your perspectives here?
Okay, I think it's, be honest, all the infrastructure software, on the state, all the vendor provides more than, I think, more than 95% of the customer install base today. So they provide a lot of the choice for the customer. I mentioned the choice is because that's the key for the customer. Because today, you asking the customer, you say, hey, microservice is good, it's still some of the user using the CICS for their business, for the banking business. So in terms of from the customer point of view, they look at the workload, and they, based on the workload, they're choosing the infrastructure to support that workload. I think as all the solution that we offer here is just provide the choice to the customer based on their needs to choosing the right platform. Moving forward, I think as based on some of the new application developed based on the microservices, container kind of the technology with a lot of the kind of the container orchestration kind of the technology like the Kubernetes or the masses. That's the way to develop the application. That's the way it can easily to scale up, to the multi-thousand or even the 10,000, but no, just like Hadoop kind of the application or the Spark-like of application, or not limited for that, because you still have kind of the other architectural level of the beauty, like some of people that are using today as CPU plus with the GPU kind of heterogeneous kind of computing. Bring that together, I think what we hear, we just provide the choice, a lot of choice based on the customer different needs. They can choose the best platform to shoot for that purpose. QCT in that way that we are very excited to collaborate with a lot of the leading companies, software vendor here, that we can base on the different custom, the choice, and provide the best platform for their purpose.
Thank you. Well, like Gary said, we have, if we look at the world from the virtualization point of view, we're saying there are three major trends, right? Like Microsoft, VMware, and the folks in OpenStack. So from the technology point of view, the virtualization moving from not just the server virtualization, storage virtualizations, and of course the network virtualization. And for all these virtualizations, there's two things. One is sort of called like time to market, right? With microservices. The other one is the cost benefit, or we say cost down. But all these things is, there's a lot of things called legacy, right? People having the computer industry or the IT industry having around for quite some time. People start to accumulate a lot of what they call the legacy. So for example, the telco provider, instead of using their own proprietary, they are moving in an open platform. And open platform, you can say, is the x86, right? In this open platform, one thing they do is they put in the virtualization layer, and they can bring in their existing or their legacy application. So again, it's a transformation because the cost issues, their aging infrastructure cannot support it anymore. So virtualization, and that is sort of more like industry specific. But on the other angle, people also within the enterprise, they move from what they call traditional infrastructure to the virtualization private cloud, right? And private cloud also give you one advantage is during the burst, you can go into public cloud. So now we have the term called hybrid cloud. So all these technology movement and trend is, like we said earlier, is the enabling technology are there, we are there, and they want to do adoption and cost down. And so I think that's also the vision for we have our solution center. You go in there, we sort of more like there's a little bit of a vertical, right? They're rack for VMware, the rack for Microsoft, the rack for Mirantis, the rack for Cloudera. But that is just an enabling portion. Now beyond that is we have a rack for software-defined storage. They can be used to support our big data appliance. We at Microsoft, we work with a big data appliance. In there, there's a SQL PDW plus their HD inside, and they can hook up to our big data rack. So I think what we want to do in this is, I think we are near the break. You can go out, check out our solution center, and give you an idea. when you play around, you walk around it, and you can generate idea. And I think what we try to do is we want to provide a platform, not just for our own use, with you and our partner, with your customer. When we come together, we sit down, we look at it, I think we're going to trigger a lot of discussion. And the discussion basic is we want to using all these new exciting technology from the traditional way or from all the OpenStack way, and we can find new way to help our customer to generate value, and also in the same time we can benefit, all of us can benefit from it. Thank you.
Well, I'd like to thank all the panelists. So we can now exit the stage as we get ready for a couple additional.
Thank you.
So if I go back to my earlier car analogy, I really think this center is a place where customers can bring their data and their applications and put it to the test in the great cars that QCT has built here in the form of all these racks of great hardware. There's really nothing like your own workloads, your own data, your own applications with the hardware you're evaluating in the form of a total solution. And so to Mike and the entire QCT team, I think it's a great facility with all the resources in place to do so. And next, I'd like to introduce some additional videos from some other QCT partners from Liteon and SanDisk. Thank you.
Hi, my name is Mike So, CEO and co-founder of Liteon. Liteon is a software-defined storage company. Software-defined storage, together with industry standard servers, is the only solution that can really address the big data explosion problem that's being fueled by advances in life sciences, finance, healthcare, hosting, and media. These industries are producing tremendous amount of data for backup, archive, IoT, and also big data analytics. We are very excited about working together with QCT because QCT is the undisputed leader in the web-scale data center space today, and we firmly believe that web-scale data centers is going to be the standard for all enterprises in the future.
As you've heard from many industry leaders today, the software-defined data center is definitely here to stay. But software-defined and the flexibility that it brings usually brings with it a set of trade-offs, particularly around storage performance. To solve this problem, SanDisk and QCT have partnered together to bring and showcase right here in QCT Cloud Solutions Centers an OpenStack implementation running on top of QCT servers on top of SanDisk's InfiniFlash. InfiniFlash is the world's first 512 terabytes of flash in just a compact 3U form factor, just the size of my palm. In fact, this OpenStack implementation delivers 10x the performance, 10x the reliability, and 10x lower power consumption than other OpenStack implementations simply running on hard drives today. And with performance like this, we expect customers in media, entertainment, oil and gas, financials, and many, many other verticals to now start using OpenStack for many, many more workloads than ever before thought possible. And with innovations like these, SanDisk and QCT are poised to change the data center world forever.